Hello everyone, welcome to my YouTube channel. My name is Wilson, and today I want us to talk about the fundamentals of artificial intelligence. And specifically, we're going to be using the project we're working on right now called SafeBite. So artificial intelligence began in the 1980s with symbolic AI, and this is where systems followed strict rules and logic to carry out decision making. Then later it shifted to statistical AI in the 1990s and 2000s as computers became faster and more data became more available. So statistical AI focused more on probabilities and data-driven predictions. So it was not basing on strict rules like the symbolic AI. Then in the 2010s, as computers became stronger, faster, and with stronger CPUs, GPUs, there came an introduction of deep learning. So here, AI uses artificial neural networks with many layers. So basically, it learns automatically from the data sets or from the large data sets provided, and it's not just using the strict rules as it is in symbolical AI. So the current trends in artificial intelligence right now are natural language processing, and this is basically working with how artificial intelligence understands and works with the human language, right? So it basically deals with the AI being able to interpret and, for example, have a conversation with a person. The common examples are AIs like ChatGPT, DeepSeek. They are able to interpret human language and basically have conversations in those specific languages. And then computer vision. This is basically how AI is able to detect, view, and process videos and images. So you can talk about tools like facial recognition, self-driving cars, and other tools that are able to recognize videos and process videos and images. And then lastly, reinforcement learning. This is basically where artificial intelligence is trained by giving it rewards when it's actually correct, and basically this helps mend the way it reasons and gives responses. So basically it's like training a pet, training a dog. So the future trends of AI are: one, general AI, and this is artificial intelligence that can basically do and reason anything that a human can. This is more in the theoretical part because practically it has not yet been or achieved yet. But in the near future, would like to see some of artificial intelligence systems that can think or reason in any way that a human can. And then even human AI collaboration. And of course, has already been implemented in the education systems. We use AIs. Our health sector, there is some use of AI, for example. So this has already been implemented. So to relate the artificial intelligence trends to SafeBite AI, SafeBite is a project that we are working on that rates restaurants in Kampala according to their air quality, congestion, food quality, customer care, and all the other factors. Symbolic AI would use strict rules like if hygiene score, for example, is less than 50%, then restaurant is unsafe. So it's basically strict rules that the computer would use to give you a response. But now, SafeBite uses machine learning to combine the different aspects, the different factors like air quality, congestion of the restaurant, uh, pricing, customer care. So it combines these using machine learning to actually give you a response, a rating that basically has all these factors together. It doesn't use strict rules or strict formats to give you a response. So in doing this, SafeBite actually reflects the logical and mathematical intelligence, since it's working with data and patterns to actually carry out decision making. It's reflecting this kind of intelligence. And as we saw that the future trends of artificial intelligence is to achieve general AI or something like a strong AI, SafeBite is a weak AI, so it can help you, a consumer, choose the best restaurant to get your meals at, your breakfast at, but it does not actually understand the meaning of the word safe. Internally, it doesn't actually. It can't reason out the meaning of safe, so it doesn't know a safe restaurant and an unsafe one. So in artificial intelligence, problems are often described uh, in terms of states, operators, and goals. And a state is the current situation of the problem, the problem you have at hand. And then operators are the actions that can be done to get you from one state or from one situation to another of the problem being solved. The goal is a final desired outcome, like where you want. So in SafeBite, we can think of problem solving this way. The initial state are the raw data that is collected from the restaurants. For example, the air sensors can pick up the data values, the air quality values, the reviews from previous customers that have used those restaurants, the congestion and anything else, and any other data that can be collected. Those are the initial states. And the operators, we can talk of the algorithms that are used to process this data in order to make or to rate restaurants. Any algorithm inside the AI, inside SafeBite, the system that's able to actually process this data, analyze it, and provide the required ratings. And then the goal state is the rating that is required, the accurate rating of a restaurant. Its score, it can be anything. It can be in percentage wise, like 80% safe, 80% good air quality, or it can be in a ratio, or it depends. And then the limitations. We talk of the frame problem. And here we say that SafeBite may miss hidden factors. For example, SafeBite does not have the ability to add any factors into decision making by itself. For example, if the chef of a certain restaurant is sick, it cannot actually add that into its factors it's using to make a decision for you for where to go and eat. So it will just base off the factors that's been using, like air quality, congestion. So it doesn't have the ability to go beyond the box. Like, we give an example here, like cultural atmosphere, or chef being sick, or your sister or family member works in the other restaurant. It doesn't have that kind of ability. So continuing problem solving in artificial intelligence, we can talk about the different types of searching mechanisms. The first one is the uninformed search. Think of it as a try and error. For example, you don't know, you have like the system has no knowledge about where the solution is, or where the goal state is, but it has to find the solution. So it's like a try and error and uninformed search. So there are two major categories. There's a breadth first and a depth first search. So about breadth first search, the system first visits the neighboring, starting from the starting node. It visits the neighboring nodes of the first node before continuing into the child or the next level of nodes. It first searches It first searches the neighboring nodes before continuing into the deeper levels of the nodes. And this has some advantages. For example, it doesn't use a lot of memory. That is one. Uh, and second of all, it can find the shortest route because it is exploring all possible nodes at a level before going into deeper levels. So it can easily find the shortest route to the goal state or to the solution. And the second one is a depth first search. So in the depth first search, the system explores a no sorry, a route, for example, a branch. You can call it a branch, as deep as possible, as deep as possible, until it finds the goal state or the solution. So if it doesn't, it backtracks and goes back to the previous state, and then backtracks again. So this is referred to as you can refer it to as the last in first out method, because you get one route expand it until you find a solution, or you find a dead end. If you find a dead end, you backtrack back, you expand the next route, then until you find a solution in that. Then the informed search is a type of search that provides extra information about the problem that can help the system efficiently figure out the goal or the solution to a certain problem. The common ones are heuristics. Is just an estimate that tells the system uses uses an estimate to figure out or to tell the system how close it is to a goal, how the node is close, how close a node is to a goal. And then such algorithm basically uses a function to figure out which node is closer to a goal state. So in our SafeBite project, we apply these same ideas of search. For example, we use heuristics by giving higher weights to critical factors like hygiene and air quality. Since these factors impact safety more than the other factors of price, congestion, customer care, right? So we also apply clustering to simplify thousands of user reviews. So by grouping similar feedback, SafeBite reduces complexity and avoid analyzing each review individually. So ultimately, SafeBite is like a search engine for restaurant safety. It searches through all available data and recommends the safest option to user much more quickly than a human could. So for AI to reason effectively, it needs a way of representing its knowledge. For example, so one common approach is a symbolic representation, and this is where knowledge is stored as facts, rules. We talked about symbolic AI earlier. So there's another one called semantic networks that shows relationships between concepts using patterns and as we talked about. So first order logic, or FOL, is a powerful symbolic system that uses predicates, quantifiers, and relationships to express knowledge formally. So, for example, we can say for all restaurants, if air quality is low, then rating should decrease. The issue about this is that we can't really formalize all human knowledge. For example, things like cultural values or personal experiences are much harder to capture in the logical rule, so you can't make it a logical rule. Relating to SafeBite, we can use a symbolic representation of our problem solving. For example, you can state like if air quality is less than 50 and hygiene is poor, so therefore rating is equal to low. So this is like setting a rule that you can use to actually uh, solve a problem. We also use linguistic intelligence to interpret user reviews, for example. So SafeBite has to be able to understand what the users are recommending, or what the users are, how they are viewing or how they are reviewing certain restaurants, and in order for us to get a correct review, for example. So it has to have linguistic intelligence in a specific language, which is basically English. Then one so the disadvantage about this is that it lacks interpersonal intelligence. So SafeBite does not really have self-reflection. After making a decision, it's a final decision. It does not actually reason about its reasoning. So inference in AI, inference in first order logic is about using reasoning rules, derive new knowledge from existing facts. The two important qualities of this are soundness and completeness. A sound system only derives conclusions that are true. Turing test argues that if a machine can mimic the behavior of all the responses of a human being, then it's said to be reasoning. But the Chinese room test that a computer may be manipulating symbols without actually understanding what it is talking about, without actually understanding what it is responding to. So even in SafeBite AI, it works in the same way. For example, in the inference, So once the system detects bad ventilation, for example, or poor feedback from the customers, it can actually infer that this restaurant is unsafe. Logical mathematical intelligence, we already talked about it, that SafeBite, for example, uses patterns and data to actually make a decision. So it evaluates data to make a decision. And then SafeBite, in conclusion, does not really understand the word unsafe, for example. It can't comprehend on a human understanding what unsafe means. It knows by a measure of percentage or ratio wise that this is unsafe or this is safe, but it does not really understand what unsafe means and what no customer care or any other emotional human factors. Moving on to reasoning under certainty. Remember that AI usually works with unclear and incomplete or noisy data, so it needs a way to understand under certainty. So Bayesian networks, I don't know the right pronunciation, are one of the solutions. They they use probabilities to model relationships between variables. So probabilistic reasoning enables systems to make decisions or to make decisions, sorry, even when the data is not clear or perfect. But the limits are, can uncertainty uncertainty really be fully captured? I remember as computers they don't have guesswork. They have to work on present data values or data sets to make a decision. So that's one of the limits. Can uncertainty be really fully captured? Planning in artificial intelligence refers to a sequence of actions that lead to a current state or to a desired goal. It is not random, but it has to go through a particular number of steps to reach to a desired goal state, for example. So each action must be directed towards a certain goal state. So therefore, to plan effectively, the system has to define the preconditions and the outcomes that it desires. Uh, so which are the outcomes, which are the results of the actions that are going to be uh, taking place. The problem here is a the frame problem where the system cannot actually distinguish from which factor to leave out or which factor to consider. We already talked about this in the previous slides. So in SafeBite, we can clearly see the planning steps that take place. For example, the system collects air data or any other information. It can be collecting views from the customers that have used the certain restaurants. It can be so any other data in line with rating the restaurant. Then the second step can be analyzing the reviews, for example. So it can analyze the reviews collected. It can actually process the air for gases like carbon dioxide, sulfur dioxide, right? So then it will on to the next step, which is computing the score according to the algorithm that it has been programmed with. So it will use the data collected to compute scores for a restaurant. For example, it can be percentage wise. So air quality can be like 80%. Uh, food pricing can be the food pricing can be fair, the quality can be fair, the hygiene and whatever. And then the last step will be publishing the rating that it has generated. So planning actually ensures consistency in evaluation. Machine learning is one of the most important areas of AI today. In supervised learning, for example, models are trained using labeled data. For example, customer reviews of SafeBite of the SafeBite project are already marked as positive or negative. So the system learns a certain pattern in order or of how it's gonna be responding. And then in unsupervised learning, the AI works with unlabeled data and it uses clustering or other techniques uh, to find natural groupings, such as grouping restaurants by similarities in their features. So SafeBite mainly applies supervised learning where we train models on past events or past user views and environmental sensor data to predict how safe or how unsafe a restaurant may actually be. And so this shows one of AI's strengths. So machine learning can process far more data than human beings, right? Because SafeBite, for example, can handle very many restaurants at the same time and give you accurate ratings and accurate decisions to make. So SafeBite has no dining experience. For example, it cannot taste the food. It cannot tell you which waiters are the best, but it can only reason from the data that is being set to reason to, or from the data sets that it was set or programmed to reason with. Thank you very much.